Algebra 2 Cram, New York State, Algebra 2 Regents, Common Core, Exponential Functions. Question number 1, Exponential Growth Functions. The odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. And if I could stick every single algebra student with a healthy dose of inner awareness of their inner mathematical genius, I probably would. Inbox me at memedicine@gmail.com to get your healthy dose by ordering and purchasing the complete cram session. All right, you have lots of friends, colleagues, and or peers who are also taking Algebra 2 with you. Tell them to inbox me at memedicine@gmail.com so that they too can order and purchase the complete cram session. You'll be glad you spread the word because they'll make great study buddies. All right, let's delve into the concept. Question 1, exponential growth function. Growth of a certain strain of bacteria is modeled by the equation G equals A sub 0 times E, this is Euler's number or the natural number, raised to the 0.584 T, where G equals the final number of bacteria, A sub 0 equals the initial number of bacteria, and T equals time measured in hours. The question is, in how many hours will 4 bacteria first increase to approximately 2,500 bacteria? Definitely press pause if you need to, and I'll give you a moment to think. All right, so hopefully by now you are able to press pause and come up with a correct answer choice, and if not, you're okay, because we're going to do it together anyway. The first thing that you're going to want to do is substitute the values into the given equation, okay? And this A should actually be like an A sub 0. So pretend that's written right here. All right, and when you go ahead and substitute values, this is what you end up with. 2,500 equals 4 times E, or Euler's number, raised to the 0.584T, okay? 2,500 being the final amount of bacteria and 4 being the initial amount, okay? The next thing that you're going to do is divide by 4 on the right-hand side and the left-hand side, getting rid of it on the right-hand side of the equation, okay? And we're doing this so that we can isolate the exponential term. So when you do so, you're going to get 625 equals E raised to the 0.584T, okay? And the next thing that you're going to do is, you guessed it, you're going to get T down from the exponent. And the way you're going to do this is by taking the natural log of both sides of the equation rather than the logarithm. The reason why we're using the natural log is because we have Euler's number, which the natural log is basically the log of base E, okay? So when we take the ln of 625, that's going to be equal to the natural log, or the ln, of E raised to the 0.584T, because remember, whatever we do to one side of the equation, we have to do to the opposing side as well to keep things organized. And now what we can do is really convenient, because we can use a few logarithm properties to simplify, okay? The first one that I'm going to use is the power rule of logarithms. And the logarithm of a base raised to a power equals, well, I shouldn't say power, because power is actually the result of an exponential function, but the result of the natural logarithm of a base raised to an exponent is going to be the value of that exponent times the natural logarithm of the base, okay? And if you don't know why this is, you have to watch my basics video on the power rule of logarithms, okay? So we're going to go ahead and represent this. So we did that. We took down the exponent and we brought it out front. So this is now going to be a product. 0.584t times the ln of e, or the natural log of e, which is equivalent to the left-hand side, the natural log of 625. Okay, and now, goody, we have another logarithm property we can use. We can use the property that says the natural log of e is equivalent to 1, because remember I said previously, the natural logarithm is basically saying the log base e, and the log base e of e, which a logarithm function is just trying to figure out what power you raise the sometimes indicated and sometimes not indicated base 2 to get the result or power that's indicated. So in order for the base e to yield a power or result of e, you had to raise it to 1, because e raised to the first power is going to equal itself. Hence, this is equivalent to 1, and we can just get rid of it since we don't have to indicate it more, since we're going to be multiplying 1 times 0.584t. Okay, so we can go ahead and re-express this as the natural log, or the ln of 625, is equivalent to 0.584t. All right. Now, in order to figure out how long it will take for the first 4 bacteria to increase to approximately 2,500 bacteria, all we had to figure out is this t. And remember, or you may not remember, the answer or the question stem asks you to round your answer to the nearest hundredth of an hour. So all we're basically going to do is we're going to flip this around and divide the natural log of 625 by 0.584. And we're going to plug this into your calculator, okay? So t is going to, again, equal the natural logarithm of 625 divided by 0.584. And when you plug it into your calculator, you're going to get 11.02. All right? And you can go ahead and put this back in this equation to check, to make sure that this amounts to 2,500. And note that if you check the rounded answer, your check may not be exact, so you might want to put in the long answer that your calculator gave you before you rounded to the nearest hundredth of an hour to get the most accurate answer, okay? But it should be something very close to 2,500. Thanks for tuning in, and as you can see, intellectual comprehension of this material was not difficult at all. And after ordering the complete Cram session, you'll be able to answer a battery of questions about any Algebra 2 concept. So inbox me at memedicine@gmail.com. If you need my email, it's right below in the description. Yeah, so do your thing and good luck studying.